Hi, I'm Ben Vaca, owner of National Design Build Services. We are a national heating and air conditioning design and construction contractor, and we do quite a bit of ARCO's work throughout the country. Today I'm going to be talking about refrigeration cycle. Refrigeration basics. Refrigeration is the removal of heat from a material or space so that its temperature is lower than that of its surroundings. When refrigerant absorbs the unwanted heat, this raises the refrigerant's temperature so that it changes from a liquid to a gas. The system then uses condensation to release the heat and change the refrigerant back into a liquid. This cycle is based on the physical principle that a liquid extracts heat from the surrounding area as it expands or boils into a gas. To accomplish this, the refrigerant is pumped through a closed loop pipe system. The refrigerant will be both a vapor and a liquid in the loop. Refrigerants are simply liquids that boil at low temperatures. By pumping a small amount of liquid through its change of state, a great amount of heat transfer takes place. We use the example of water because properties are easily observed and its behavior is similar to commonly used refrigerants. After a fluid has been heated to the boiling temperature, further addition of heat at that pressure results in evaporation of the fluid. The heat required to change a fluid from liquid to vapor is called latent heat of vaporization. At standard atmospheric pressure, it takes 970 BTUs to completely evaporate 1 pound of water at 212 degrees Fahrenheit to steam at 212 degrees Fahrenheit. So as you can see, the change of state gives you 970 BTUs absorbed or given off, and you only get 152 BTUs going all the way from 60 degrees to 212 degrees. So the change of state is so important for refrigeration, for both evaporation and condensation. A basic refrigeration process, whether it's the residential system in your house or the most sophisticated commercial system, it'll always have 4 components. You'll have your compressor, your condenser, your expansion device, and your evaporator. So here's a video of a refrigeration cycle, which I believe will be much easier to follow. So your compressor is the heart of the system. So compressor does just what its name is. It takes the low pressure refrigerant vapor from the evaporator and compresses into a high pressure vapor. As the pressure increases, so does the temperature. Its sole purpose is to increase the refrigerant pressure, thereby increasing the temperature above the outside ambient temperature so it can be cooled and condensed back into a liquid. As the refrigerant enters the condenser, the high pressure, high temperature vapor is cooled from approximately 130 degrees to around 115 degrees Fahrenheit and condensed back into a liquid as the outside air passes across the coil. The high pressure liquid travels through the filter dryer and into the thermal expansion valve. The purpose of the expansion valve is to lower the refrigerant pressure by creating a pressure drop. As the liquid refrigerant passes through the expansion valve, the high temperature liquid changes to a low temperature vapor due to the drop in pressure. Around 25% of the liquid boils off, dropping temperature of the remaining liquid from 115 degrees to 40 degrees. That temperature remains the same through the evaporator as it absorbs latent heat from the conditioned space. So basically you got your return air coming across your evaporator and boils off the refrigerant. So when all that refrigerant is boiled off or vaporized, it's now a saturated vapor. That low pressure vapor is then returned to the compressor and the process starts all over. So in summary, the compressor raises the pressure and temperature, the condenser condenses the vapor into a liquid, the expansion valve lowers the pressure and temperature, and the evaporator boils and evaporates the refrigerant.